case we will differentiate. Oh. I bring 2 down and simplify, so it's x over 8. This is just a number, I don't care for it. I bring down 2, 10 minus x times the inner function prime times the square root of 3 over 36. Now I simplify. I do have a little bit of a fight because I have to solve the equation. So let's see how we simplify this as much as possible. It's not a friendly equation, but we can do it. Okay, so this is x over 8. This is minus 10 minus x, the square root of 3 over 18. I'm going to separate it to x over 8 minus 10 the square root of 3 over 18 positive x the square root of 3 over 18. Here I'll simplify a little bit. So I have x over 8 plus x the square root of 3 over 18 and minus 5 the square root of 3 over 9. Getting there. And I'm going to write it as x 1 over 8 plus the square root of 3 over 18 minus 5 the square root of 3 over 9. So when I set this equal to 0, I have to set this equal to 0. X 1 over 8 plus the square root of 3 over 18 must equal 5 the square root of 3 over 9. Very ugly, but doable. This is at the top, and this is in the denominator. As is, I'm going to punch in everything. Not going to waste my time anymore with that. Careful with the top, parentheses, 5, the square root of 3, outside. Do I want parentheses in there? Let's say, it's going to do it correctly. Okay, divided by, in parentheses though for the denominator, 1 divided by 8 and plus the square root of 3, and it's divided by 18. Don't torture me, just give me the number. I'm checking to make sure everything is okay. Yep. 4.35. 4.35. And that was in meters. Okay. I have to erase that. In this particular case, this is very important. This is a closed interval. Why? So this is, x could be 0 or could be 10. There is nothing else. It cannot be more. It cannot be less. X could be 0. So I bend everything into the equilateral triangle. Or x could be maximum 10, and I bend the whole thing into a square. So this is maximum 10. Okay, where is my first derivative? Is here. This time, I have to put the function as well. I'm going to enter this function in my calculator because I want to determine these values as well. Ready? Let's study the sign. So again, let me finish with the sign. So in the derivative, where are you, my derivative? Okay, my derivative is here. So if x is 0, this is negative. And if x is 10, it should be positive because it's a linear function. I don't really have to check. It's a linear function with a positive slope. I don't need to check. It must be this, from negative to positive. But now I want to determine these values. So I'm going to put in the graphing calculator the function, which is, because I want to put three numbers and I want to put the function in. So I have x squared divided by 16, and then plus outside, in parentheses, 10 minus x, close parentheses, squared. And then I have the square root of 3. And then completely outside, make sure you divide by 36. Okay. I'm checking. X squared over 16 correct. 10 minus x squared is correct. The square root of 3 is correct. And yeah, second and table. And I want 0, I want 4.35, and I want 10. For 0, I got 4.8. 4.81. For 4.35, I got 2.72. And for 10, I got 6.25. Okay. That's one perfect example on how to study a function on a closed interval that we did a while back. So I'm checking to make sure that these two rows work well together. From 4.81 to this, yes, it's correct. From 2.72 to 6, that's correct. And now I have to make a decision. This is the absolute max. And this is the absolute and also local min. So when the problem was asking us to find the dimensions or where to cut the wire to get a minimum surface area, I would say you have to cut at x 4.35, and y is the difference, 10 minus 4.35. If you want the absolute maximum, you have to allow x to be entire 10. Do not use the equilateral triangle. It's not going to work. It will diminish the area. The maximum area is obtained when you use the entire wire to bend it into a square. That will be the maximum, absolute maximum, 6.25 meters squared. If you want a minimum, then bend this 4.35 into a square, and this 10 minus 4.35 into an equilateral triangle for the minimum area. Any questions? I will post a previous test 4